In the previous video, we built a text-to-SQL module that lets people to query a relational database using natural language instead of SQL. That opens up some exciting possibilities. Product managers, analysts, QA engineers, even business users can explore data without asking a developer to write SQL. Today's video is much less exciting. No AI magic, no new features, no flashy demos. It's simply about my engineering perfectionism. The module already works, but one detail kept bothering me. Every request rebuilds the JSON representation of database schema from the information schema tables, even though the schema itself rarely changes. So I decided to add an optional schema cache. Not because the project needs it today, but because it's a kind of infrastructure I'd expect in a product-ready system. Before the LLM can generate SQL, the module queries information schema, builds an in-memory database schema snapshot, and serializes it into JSON for the prompt. The problem is that this entire pipeline runs on every request, even when the schema hasn't changed. The solution is a caching layer between Text-to-SQL and the MySQL schema discovery logic. It consists of a cache service, MongoDB for storage, and a Mongo provider that keeps the whole feature optional. Instead of rebuilding the schema every time, the module asks the cache layer for the schema context and only returns to MySQL when necessary. Let's walk through the main pieces. MongoConfig defines the optional MongoDB configuration. If MongoDB URI is set, caching is enabled. Otherwise, the module simply uses the original MySQL flow. MongoDB is an optimization, not a hard dependency. In Mongo Provider, we create an isolated Mongoose connection for the cache layer. If MongoDB is not configured or becomes unavailable, the module falls back to MySQL. Disabling buffer commands prevents requests for waiting while the connection is down. Both files live under provider's Mongo, keeping the infrastructure code in one place. I added a new schema cache configuration section with a single option TTL milliseconds. It controls how long a cached schema remains fresh before revalidation. For each MySQL database, MongoDB stores one document keyed by host port database. It contains the schema snapshot, a fingerprint for change detection, and a pre-formatted JSON version ready for LLM prompt. The fastest path is a fresh cache hit. While the document is within the TTL window, the module returns the schema from MongoDB without running any schema queries against MySQL. When the TTL expires, the module doesn't immediately rebuild the schema. It first runs a lightweight fingerprint query. If the fingerprint is unchanged, it refreshes the timestamp. Only a changed fingerprint triggers a full rebuild. The fingerprint query returns 3 aggregated values calculated over all columns. Comparing this small fingerprint is much cheaper than loading and serializing the full schema again. All caching logic lives and schema cache service. Text-to-SQL service knows nothing about MongoDB, TTLs, or fingerprints. It simply calls getSchema for prompt. Schema cache service then decides whether to use cache, rebuild from MySQL, or fall back when the cache is unavailable. I benchmarked the same query with and without the cache. The difference was barely noticeable. On my demo database, generating the schema JSON takes only a few milliseconds, while the LLM call dominates the total request time. In the end, I built a pretty nice caching architecture for a problem that barely exists in my demo project. Maybe I should have measured first. On my setup, the schema generation isn't the bottleneck, but on larger systems, this kind of cache could make a difference. In the next videos, I'll benchmark this model against much larger databases and see where schema caching really starts to matter. If you enjoyed the video, don't forget to like and subscribe. And if you've got ideas for further optimizations, let me know in comments. Thanks for watching and see you in the next one.